In today's video, let's quickly break down a concept every modern developer should understand: virtualization versus containerization. Both let you run multiple applications on the same hardware, but they do it in very different ways, with big implications for performance, scalability, and DevOps workflows. Virtualization, left side. On the left side of the diagram, you can see classic hardware-level virtualization. Here we have physical hardware at the bottom, and on top of that sits a hypervisor like VMware ESX, Microsoft Hyper-V, or KVM. The hypervisor's job is to emulate hardware so you can run multiple virtual machines, each with its own full operating system and applications. Each VM is like a complete computer inside your server. VM1 might run Windows with a couple of apps, VM2 might run Fedora, and VM3 could run Ubuntu. Because every VM includes a full guest OS, this model gives very strong isolation and the ability to mix different operating systems on the same physical box, but it comes with higher overhead in terms of CPU, memory, and storage. Containerization, right side. On the right side, the stack looks different. At the bottom, we still have the same physical hardware, but now we run a single host operating system that exposes its kernel to everything above. On top of that host OS sits a container engine or runtime such as Docker, Containered, CRIO, or Podman, which manages container lifecycle, networking, and isolation. Instead of full virtual machines, we create containers for each application or service. One container for App 1, one for App 2, another for a database like MySQL, and so on. Each container is an isolated user space environment that packages the app with its libraries and dependencies, but all containers share the same host kernel. This makes containers much more lightweight and faster to start than VMs. Key differences and when to use what. So, what are the big differences? Virtual machines virtualize hardware and include full guest operating systems, which gives strong isolation and is great when you need to run different OSes, host legacy apps, or build strict multi-tenant environments. Containers virtualize at the OS level, sharing the kernel, which gives lower overhead, higher density, and very fast startup times, perfect for microservices, cloud-native apps, CI/CD pipelines, and auto-scaling workloads. In practice, most modern architectures combine both. You might run a cluster of VMs on a hypervisor for infrastructure isolation and then run dozens or hundreds of containers inside those VMs using Kubernetes or another orchestrator. Understanding this diagram helps you choose the right layer for your use case and design systems that are efficient, portable, and easy to manage.